what's going on? What is going on? It's 3 a.m. there. What are you doing? What are you doing someplace where it's 3 a.m.? That's ridiculous. Why would you do that? How does that even make sense? How does it even make sense? Good morning from the UK, 8 a.m. Right on. Right on. I was just in London like a month ago at this point. Maybe a little less. A little less. I was in London on like July 5th, man. Is that really true? Can't be true. It must have been June 5th. Must have been longer ago. I don't know. I have lost all track of time. Good morning from Denmark. Crazy Danes. Crazy Danes. All right. Well, I think I'm going to pick up at the point at which we left off on the last stream. I did a bunch more stuff on the compiler, but nothing you would notice. It was internal cleanups of other things that did not change the running speed much. It was a big cleanup, though. I'm very happy with the thing that I did at work today. It was something that needed to happen for a long time, and now it has happened. So now we're going to pick up where we were at the last stream, which was we're eventually trying to optimize, but I doubt we'll even get there tonight either. Although maybe, we shouldn't be negative Nancy. We're trying to initialize the sizes of known data types early in the pipeline, and then we can delete all the ones that come later and have a much cleaner separation. That might make the compiler a little bit faster. Probably not super noticeably faster, but that'll be cleaner, and it's half of what we need to do to set the stage for being able to parallelize some of this stuff. I was also thinking about it today. After we do some of the other stuff we're going to do here, so we can parallelize these later sections, the part of the compiler that I was always saying was super hard to parallelize, which is the type inference part, I'm not sure I'm that scared of it anymore. Like, it'll be a really big refactor because it's a lot of code. Like, this file is 10,000 lines, and it'll affect other things too. But I'm not that scared of it. We'll see if I'm foolish to not be that scared of it. Yeah, I mean, obviously I fail programming school because in programming school, this would have to be broken up into procedures of no more than 20 lines each. So instead of one file here, it would be 500 files. More actually, because when you break it into 20-line procedures, you have to call the other 20-line procedures. So you don't get the number of lines divided by 20. You get more than that. What's the purpose of having a multi-threaded compiler if you can instead compile 9 files at a time and therefore also use 8 threads at 100%? Do you mean 9 files in separate processes? Because otherwise it's multi-threaded, right? So you're saying if you can compile 9 files in separate processes. Okay, well, how does the data in those files talk to each other? How do you compile 9 files? How do they reference common elements? Do you know what I'm saying? Headers. What's the slowest part of C and C++? Language server protocol. You could get away without headers. You could do things like, you compile a file and that makes a module summary that somebody else loads. But then you start serializing on a really granular scale. But the point is, if those processes never talk to each other, you not only need headers, but you need object files. You need to write the shit to disk and then link it together, which is the other slowest part of C and C++. So you're talking about all the slow things. Like when you think of all these really impressive video games that are basically the height of current computer technology, that are rendering all this cool stuff and animating all this cool stuff that's happening all the time, drawing all these cool effects on the screen. Do you know what they don't do to make all those effects appear on the screen very efficiently? They don't run 20 different processes, write binary data to disk, load that data back in, connect it up, and draw it on the screen. They don't do that. That's just not how it works. Thank you for being Europe friendly with your work schedule. Yeah, this is pretty random. I might get tired pretty soon. This might be a short stream, but I just felt like turning it on and starting streaming. Since following along with Handmade Hero, I have truly seen the light of never using methods ever again. Yeah, I differ from Casey on that. Like, I use methods somewhat. Like, if you watch me program here, I definitely have structs with methods, but I mean, even I am trending away from that over time. Like when I parallelize this code, it's probably going to get less methody, less Methodist. What am I wearing? This is a t-shirt. It's a band t-shirt that I got in 2003. I don't know. What year does it say on the back? I think it's 2003. Two, 2003? Yeah. Too small? Oh well. This shirt has no sleeves because I took them off. Because that's what I do with dance shirts sometimes. It was a t-shirt. Isn't the comparison of games and compiler a bit unfair? Only in the sense that I'm comparing high technology with low stagnant technology. That's how it's unfair. Compilation is often done every few minutes, and you can always cache build intermediate linking stages. If you can always cache and build intermediate linking stages, then why does it still take so long to build my games in my compilers? Games are much simpler in nature concurrency-wise? What are you smoking, bro? What? Okay, now you're just making stuff up. I'm sorry. You're just making stuff up. It's okay. I mean, if you don't know that much about games, it's fine. It's just, it's not true what you said. They're way harder than compilers. It'd be awesome if I start a trend of innovation in compiler tech. That'll be pretty hard, honestly. We'll see. I mean, I will just be content if I make a good compiler, one good compiler. Why not have a bunch of smaller units? I just explained that. I guess you just tuned in. I literally just explained that 5 minutes ago. You can go back and look at the beginning of the stream for the explanation. Which part is more complex concurrency-wise? The whole thing, dude. I can't. It's not. If I sit down and do an impromptu why games are complicated stream, I won't get any work done. Just don't take my word for it. Just try to make a modern game. Try to make a AAA game and come back and then you'll know why it's complicated. Okay, so I think my strategy is just to try turning back on this init size, and we'll just see how bad it breaks. Oh wait, before we do that, let's verify that everything works in both debug and release, because I did do some big changes today, and who knows, there's a small chance that I messed something up that somehow I didn't notice. I guess I already did test release here, but we'll test debug. We'll make sure it doesn't assert. Because if it's asserting on something and then I go change that other thing and I run and it asserts on the first thing, I won't even know that they don't have to do with each other. You know, it gets very confusing. Uh-oh, not all control paths return a value. Okay, that's not good. That's something I did today. It's on my list to get rid of this if, but we're just going to do that. And we'll check that in because fix missing return. Right, is that the only change? Yeah. Okay. All right. Gonna run debug builds. And then we'll even run it with LLVM, and then we're ready to go. Okay, LLVM version. Do I think it's better to have 1,000 good programming languages in fragmentation, or as few as possible so almost everyone speaks the same language? Well, I can't really say because I've never seen a world where we have 1,000 good programming languages. I mean, there are probably some programming languages you could call good. It's a minority of them. There are 0 good programming languages for what I do. I would actually say, I would say for my own purposes, this language is good now. It's just that the tooling is not, totally up to par with other languages. But yeah, it's not like I have this surplus of really good programming languages and I can't decide which one to use. That I wouldn't have made a programming language if that were the case. Okay, so we're going to do this, and we're going to see how bad it breaks. It always surprises you that not all control paths returning a value is a warning, not an error. Well, if it's not in the language spec, it can't be an error, but also, like, historically, the data flow analysis that produced those kinds of warnings was not foolproof, which is why it was a warning. And in fact, I think to this day, there's probably still false positives in the algorithm. So there are things where it's always returning a value, but the compiler can't probably tell. They're probably very rare cases, though. I don't know. Okay, let's see what happens. Boom. Okay. Let's do debug build of that. Why isn't there a nil value emote still? Good question. Good question. It would make sense to have one. Maybe we'll make one tonight. Defen was null putter. Force infer. Why would a force infer produce a different result than it did when we weren't initting sizes? That is interesting. Okay, we're resolving overloads for some procedure call on line 698. Quick sort with our little funky quick lambda. How do you like our quick lambda? Okay. Type check one overload. Sort call arguments and maybe polymorph. Okay. So wait. Okay, we had that nullify inferred type. Why are we getting here when we wouldn't have before? Set inferred type to null. Oh. No, this isn't a bug. This isn't a new bug. This is just that this check. Okay, we're going to use nullify inferred type down here, though. But we used to set inferred type to null all the time, and it wasn't a problem because we didn't do anything to the thing. But now we do. Okay, see, I'm stupid at night. If I'm this dumb and I can still make compilers, anybody can. Okay. Nullify inferred type. Whoops. See, look how dumb I am. You don't need to pass null to nullify inferred type because it knows it's null because we're nullifying the, like, what school did I even go to? What computer science school did I go to where they didn't teach me that with nullify inferred type, you don't need to tell it that the value is null? What kind of crappy computer science degree do I have? Oh, wait, I don't have one. Okay. Let's make sure we don't. Whoops, I was about to remove all the slow breakpoints. I couldn't tell if we successfully ran, so let's Control F5. Why is it taking so long to... Failed to write the output file. Dude, we compiled the whole program. Oh, this is good. This is good beans. That's the opposite of bad beans. It's Nick Cave and the bad beans, but with good beans. It's Nick Cave and the good beans. Oh, this is so good. Holy crapoli, this is good. This is a really good day. Like, you guys didn't see the stuff I did at work or know how much it needed to get cleaned up, but like that plus this might make this the best compiler programming day in the past year, possibly. Except for that other day recently when we made iterators work. That was a good day too. Been a long time since I did a music stream. We can do another music stream sometime. I don't think it's today. Now things are really moving on the compiler front here. Okay, so this is really good. I'm gonna run all the tests in debug because, and then all in release. And then we'll just check this in. And then we'll start deleting all the old init sizes, which I think we should be able to get rid of approximately 100% of. And that'll be amazing. All right. This will take a little bit to run. The new emote day was a good day. It's a pretty crappy emote, but I had fun making it. Yeah, this init size thing was one of the biggest messes in the compiler. I mean, we haven't finished cleaning it up yet, so there might still be more problems, but this was one of the biggest messes in the whole compiler. And the thing that I cleaned up today was one of the other biggest messes in the whole compiler. There's still messes, don't get me wrong, but these were the biggest ones. You actually recognize the emote. See, it's a successful emote if someone recognized it. 60% of the time, they recognize it every time. I really like that emote because like it's kind of shitty looking, just like the cologne. Do we use some specific framework for testing? Abner wrote a little test program that just runs all these things. It's not really a framework in the sense that it's not 500,000 lines of JavaScript. So if you skip all the file names and stuff, it's about 500 lines, which still seems like a lot, but it does some things. But that was the whole program that I just flipped through. How do I think streaming the Sokoban game's development has affected the development process? I don't know, because development of every game is different, and development of games at different times is different. Just because technology is different and the internet's different and whatever, so I can't separate out the part that's streaming it versus anything else that we would have done normally. I mean, we're doing this game in a totally different programming language that I'm making while making the game, which we've never done before, and that makes it different. So I can't compartmentalize. Will we have networking primitives? No, that's not a language feature. That's a library feature. Except, of course, we will, of course, have the LSP keyword. That sends whatever follows that keyword on the language server protocol. Is there a library to go up the object hierarchy? Right on. I'm running a lot of tests, but I'm just being paranoid about this. All right. Every time I think of a new buzzword for a future stream title, I'm writing it down. Okay. All right, let's check that in. This really scares me that it was that easy. Like literally, the only flaw was not checking that the pointer wasn't null. So last night when I signed off the stream because I was tired, we were literally like 1 minute away from succeeding, which is fine. I'm very happy with it. Okay. Init size in set inferred type. Okay. So I'm just going to keep running debug builds, but I'm going to remove some init sizes, right? And so the reason I'm running debug builds is because a lot of things assert that the size of something is non-negative. And here's what I'm going to do. For now, I'm just going to take a couple of these. I'm going to comment them out, and I'm going to say assert desc type size greater than or equal to 0. There might be other asserts that would catch it, but we're just gonna do this. I'm going to be bold and do 3 of them to start. There are 83. We can't delete all of them, but almost all of them. So, you know, we're hoping to delete about 80 of these, which will remove 80 lines and get us back to the 4825 range, which will be awesome. You guess all the refactoring is paying off? Yes. Dude, I feel so much better about the compiler even than I felt this morning, much less, you know, weeks ago or whatever. Okay, that was 2. Let's do one here. Oh, that's ridiculous. We don't need to frickin' init that side. I'm just going to delete that. Actually, no, let's do it. Let's do it. Assert def in size is greater than or equal to 0. We know it's 1 because we set it to 1 at startup, but we're just being paranoid. Relative pointer type size. All right. So we've gotten rid of some init sizes. And then we're going to run all the tests because I'm just being paranoid. Well, we'll run the tests if the game survives. Let's get rid of these breakpoints. I think it worked. Whoops. This is such good news. You have no idea. Well, you might have some idea, but you have no idea what good news this is. This is such good news. Good news. This is gooder news than that magazine that the Mormons bring. Or whatever. No, that's Watchtower. What church brings good news? Is that like the... What does init size do? Is it Catholic? Okay. Init size, basically there's an integer. So, okay, there's a syntax tree node that represents a type. And anytime you create a new type in the language, it gets a new node, right? So an integer type will have a node saying what kind of integer it is, right? And then every type has a size value on it that people can just read to know how many bytes that type takes to store. And that size is not necessary for type checking, but it is necessary to generate code, right? Because If you're going to put something on the stack, for example, you need to know how big it is. You know, if you're going to read a member out of a struct, you need to know the sizes of everything before that member, because you need to know where in the struct to look for the memory. Jehovah's Witnesses? Jehovah's Witnesses. All right. I don't know. Somebody gives out good news. Look how good this news is that we're getting. You know what? I am emboldened. I'm just going to like randomly delete a bunch of these. Actually, before we do that, we're going to let the tests finish. And we're going to make sure the game runs, because we didn't do that. And then I'm just going to like delete 10 of them each time. And if everything passes after that 10, we check in. And that's like 8 check-ins at most, but so is that size now inferred from the primitive types or some other way? No, what's going on is there is a pipeline stage called pipe size, which was after pipe inferred, where things were supposed to get sized. But the architecture of the compiler, like the way things work, it just didn't really work that way, that things could really get sized there without writing a ton of really annoying code that would be slow. So what I ended up doing was saying, oh, I'll figure out the right way to do it later. And then every time in the back end that a size wasn't ready for some reason, I would call init size on it, which is why there's 80 init sizes sprinkled all through the code. Those are just the places where for some reason we got there and the size was still -1 when it shouldn't be. It's like a terrible hack, right? But you know, having been forged in the fires of the game industry, I am totally fine with terrible hacks as long as you go clean them up. You know, you can use them as a crutch to get you somewhere. You have to lay down the crutch at some point, though, and that's what we're doing right now, is we're laying down the crutch. And that's really the only problem with a lot of code that people release, is they just don't do this. They get to a point and then they're like, oh, I guess it works, it's done. And it's like, no, you gotta. All right. We're gonna delete 10 of these. 2. Oh wait, I was gonna make sure the game runs. Okay, here's what we're going to do. We're going to do 2 batches of 10. Check in after each. And after the second one, we're going to do a release build and run a Benny test. Just to... Of course, I haven't run a Benny test in a while, so if it fails, it might not even be this. Okay, this is a comment. But we're going to delete that code. 5. I'm trying to just scramble around where I do these. 6, 7, 8, 9. I also have to check and make sure there's not some function here that would have side effects, but 10. All right. So that's 10 plus, you know, the couple we did before. So we're going to do another test. We'll also do an LLVM build. LLVM, dude. This is good news. This is good news. Find and replace init size with assert. Let me see. I mean, the problem is there's a couple that we need. I'm just going to do it this way, although you're right, it may be faster to do that. But we're like, no, you know what? You're right. You're right. Okay, here's what we're going to do. We're going to replace init size with assert size. We're just going to do this test. Yeah. Okay. Okay, we're going to have define assert size, interp defin, assert defin arrow size is greater than or equal to 0. That's it. So we're going to globally replace all init size. And then we're going to go back and re-replace the couple that we actually need. And if we goof, then those asserts will go off. Okay. Break that in the middle. That seemed to have been succeeding. Okay, so what ones do we need? Well, we need this one right here. And then, so we might have some init sizes early in the pipeline, like in typer, that'll go off because they're happening before this. But in most cases, those should just be cosmetic. Maybe we'll sweep for those first. Oh, our declaration of init size. Oh, God damn it, dude. It destroyed our macro because Emacs didn't. Jeez, whatever. Okay, we got to do this again. Assert size, interp defin, assert defin, arrow size greater than or equal to 0. Okay, we'll just do that. This is init size. We got to do the procedure declaration down here. Where was that, though? It's in ast. These init sizes we probably don't need as well, but I have a separate to-do list item for getting rid of those. Okay, and then we probably have in pipes. Oh, this was our old thing. So here, if there's a struct, we say struct has been sized. God, Emacs, it's getting so frustrating that I have to do this all the time. I just want to slam it into the wall. It's almost making me want to try a different version of Emacs, but it's never been fixed. So, assert size. All right, we're just going to try it. I may have forgotten one. Oh, let's scan for init sizes in typer, or assert sizes, because those are too early, probably. But they shouldn't be necessary there. How do I deal with friend loss like a close friend dying? I have not had that happen, so I cannot tell you. I may look ancient, but I've been pretty lucky. I also haven't been the kind of person who has a zillion friends. I just have a smaller number of friends, and that makes it a lower probability event that my friends die. There aren't any in typer. Oh wait, there are a couple. This might count as in typer for value bakes. That's probably an assert. Okay. This is a loop that actually takes time, so we want to get rid of that. This is always going to fail. Oh. This should just be assert false. All right. Can you have a lot of friends and be a serious programmer? I don't know. What is Emacs doing wrong? When I modify files, for example, from Visual Studio, I have Emacs set to auto reload them, but its auto reloader is wrong now and reloads the files too early before they're done being written. And then it realizes it doesn't have the whole file, so it marks them as modified. So then I have to go like revisit the files all the time. Or except sometimes it even does that twice in a row, and then it gets stuck on this prompt of like, do you really want to reload the file? And it's like, yes, because there's no modifications, because the modification you think is there is when you failed to hot reload it last time. It's just so stupid. And it used to work, and it just broke in some version of Emacs, and they've never fixed it, as far as I know. You think it's a file system issue, not an editor issue? No. It's just that the semantics of change notifications in Windows is that they happen before the file is done being modified. So you just need to do some extra work about it, that's all. It's not ideal, but it's not that hard to make it work right. It's just people aren't paying attention. All right, wish us luck. We are asserting size. Right. This actually makes sense. Because sometimes we make pointer types. All right, we can patch this. Sometimes we make pointer types by like making a type and then making a pointer, and then we set the inferred type to the pointer. All right, let's see. See about that. There may be a number of cases like this. I'd be surprised if that was the only one. And that was weird. Should have already computed struct size, but didn't. Oh. Yes. So this thing that we just added is not right. See, now I'm worried. Let's see. Yeah. See. This is a oh. Really? Where did this type come from? Oh, it's a pointer to something polymorphic. 512, let's double check this, but flag 512 is type definition is polymorphic. Okay, so what's going on here? This actually isn't supposed to have a size. So oh, and we do put polymorphic types into the type table. Did init size just not do anything with polymorphic types? Let's check that. Type leaf. I guess it would just, no. I mean, I don't quite understand. Okay, well, let's assert there, and let's understand. Let's not just paper this over. Okay, so we're going to go here, and we're going to say no check-in. Actually, I want to know. Yeah, this is also marked polymorphic, but we'll do this. So if it's a pointer to something polymorphic, we're going to do init size on it because that's what this used to be. And then I want to see what happens. Because, oh, you know what? It would have just said it's a pointer. Right, I got confused. Okay, we would have called init size on just the pointer. So it would do size of, and this didn't used to be here. Yeah. So we have to add an additional case. So if it was a pointer, even if it was a polymorphic, even if it's a pointer to something that we don't know what it is, we know the size of it. So we would not feel the need to go down and look at it. I'm actually not sure. Okay, but wait, so def and arrow size is -1. Oh. Okay. Okay. Our init size is not correct anymore. Or not that, our prelude to init size, okay. Okay, people, we have achieved understanding. So we may need this thing that I typed here, but I'm just going to comment it out for a minute. The deal is what I just said. Actually, there's a number of things. Like if it's a pointer, or if it's an array of unknown size, then we know the size. It sounds array of unknown number of elements. We know the size of the base array struct, and even for lambdas, okay. So this excluding polymorphic up here wants to be different. Here's what we're going to do. We're going to say if it's polymorphic, we're going to exclude a couple things. If it's polymorphic, if not pointer to or array element type, actually, I mean, this is annoying because not all arrays, okay. Okay, so if skip, we just frickin' do this. Return. Okay. Get array type. Get array type. Where's that even defined? We're just going to local this. Actually, it's inline. If not defen flags and is unknown size array. So those are the things we skip. Dynamic array, unknown size array. Okay, we may still have problems. Who knows? Could anyone help with your C++ school project? Does it involve AWS Lambda? Is my question. Did I screw up? Wait. Wait, is this a new thing that I just, yeah. Okay. Pointer 2. Okay, so assert size also needs to, okay, assert size is wrong. Because polymorphic, if not, if it's polymorphic, it's a lot. It should have size -1, actually. And there might be some other flags that we need to check, for all I frickin' know. Definiton is polymorphic. Definition. Don't have a definition fit. I'm hungry. Oh. 256. line 83 of preload. Okay. You know, we probably don't need all this garbage up here, honestly. So this flag is type info in progress. Okay, where did this come from? Get inferred type of decal. That means it should have been set with set inferred type. So let's catch these things. Let's catch these here. Wait. My skip is wrong. Wait. My skip is wrong. That's not really the problem, I don't think, but let's see if this trips. It probably will. You set skip equals true. Yeah, that was wrong. It was wrong. You have a class with Morse letters. Now you have to input a word or a letter like A, and it should print out in console dot dash. Okay. Piece of advice one, don't think about classes because class or not class has nothing to do with the answer to that problem. It's in the same place. This is so weird, dude. I mean, the size is -1. Okay, this is defen is ACFA0. Here, we're getting the inferred type of the declaration, which is, oh, it's a different. It's different. Oh no. Oh, it's array element type. It's not polymorphic. So this is like we made an array of something somewhere. All right, this was line 83, right? What was that again? We made an array here. And it's the same thing as with the pointer. We did set inferred type on it. So this one has a size, yes. This one has a size, still the same one. But array element type, we don't initialize. Yeah, I mean, I think init size is going to have to be a generally recursive scenario. That's fine. It's fine. So this is polymorphic. Did I add this? Like, this is polymorphic. I don't think I added that. Makes me worried. It makes me worried. We're setting the size to -1 and then saying assert size. What? Why am I doing that? Oh, because we're trying to recompute the size? That's not, this should not ever be a thing. I must have been doing that for some debugging purpose and left it in. All right. Water particles. Dude, we're getting into the game. We're out of the preload. We're like somewhere random. Let's see what our pipeline state is. It's okay. A lot of things made it through the infer pipe. Most things, actually. Or I don't know about most things, because we might load more. But a lot of things made it through the infer pipe. Oh, wait. Yeah, a lot of things. I don't know. Whatever. I don't remember. Okay, so we have something, the size is less than 0. And it's not a struct. We're asking type of something. Okay, it's line 188 of water particles. Oh, this must be size of. Oh, dude. Wait, what? Okay. Type to query is going to be a pointer. Okay. So the problem here is that this is a type that is never the inferred type of anything. It's in fact a type valued expression. And so it doesn't go through that piece of code that we just did. So yeah, we need to do I'm going to make it just something up called conditional init size, and we're going to refactor our current stuff to be called that. value of a type valued expression. Probably we set an expression substitution to a type. Thus, we would catch all defins early in the pipeline and not have to worry about their sizes being inated later. Okay, I think that type valued expression one is not the right way to do it. Wait, here we can't even do it because this is going to get filled out. Okay. Whatever, dude. Okay, I'm starting to get tired tonight, and so this might be not totally solved tonight. Okay. So we're going to go back to this. Conditional init size is going to be this thing. I guess. Okay, get alignment. This is a totally different place, I think. Line 906 of UI. Oh my God, we're most of the way through the program, dude. We are close. (906). Pointer to a bake. I bet we baked this procedure. And when we bake the procedure, we construct a type, and we don't init size on it, probably. Right? Right. Let's find out where this gets made. Good idea, whoever told me to put the assert in. I mean, we probably don't need about half the conditional mess that I added, but we can simplify that out once it works. May take a while to find out where this is. Ignore me too, but not this sentence. We're just chilling. We're just sitting here waiting for this to happen. We're just waiting. Waiting. We are waiting. We're just waiting. How come everybody has this sad emote now? Or is that just a couple people using that? Or is it just one guy using it and I just see it a lot? Oh, you just use it all the time. I see. I see. I see how it is. What are we working on? Why do people ask me what we're working on when they can just read the thread title and be fully informed about what we're working on? I mean, obviously what we're working on is waiting for the breakpoint to happen. This is the downside of it happening almost at the end of compilation. Am I sure the program is running properly? I'm pretty sure. It's just at the end. Why does the program slow down when you use breakpoints? I'm not sure, but so this is a conditional breakpoint here, right? So probably Visual Studio's expression evaluator for the condition is really, really, really slow, right? So this is a code path that gets hit for every single syntax tree node. So it's like hundreds of thousands of times, or millions of times maybe even. And it's evaluating this expression each time. At some point, I should just make an if statement. That would have been much faster. Yeah, I could do the if statement version. Yeah, I do that sometimes. It's just usually it's not this bad. But this is like I was saying toward the very end of the Sokoban compile. Well, it's not just evaluating it each time, it's parsing your conditional expression and interpreting it before evaluating. Yeah, probably. It probably is doing that. And knowing Microsoft, it's doing it by constructing COM objects, right? It's every single time it's doing an IEnumerate for the COM objects that will create the expression parse tree. Okay. Maybe after they finish making their linker only 100 times slower than it should be, they can work on this. I hope that's still the right number. Gee, look how long that took. Okay, where are we at? Check function header. We're making a type definition. But we're calling set inferred type. Oh, but we're calling it, okay. So the problem is we've made a type. It's not, it doesn't have all its flags and stuff. So we're init sizing it early. Oh, we may have this problem several times. Okay, anyway. Like we're making the type and we're setting the type later. Yeah, we might have to audit for that. This is dangerous because because if we change the type after we set, it could be the wrong size. Wait. Actually, no, hold on. What am I talking about? It's the arguments. Hold on. Okay. So the thing is, it's a Lambda. There's code here that's like disagreeing. Anyway. We're getting alignments. See, this is still probably polymorphic. Yes, it's got 512. So why are we getting the alignment of a polymorphic procedure? That doesn't make any sense. Okay, wait. This okay, there's a member that's polymorphic. Why? This is one of those things where your code was doing something weird for years and you're like, why? Okay. Let's just see what this is. It's UI in line 906. Oops. It identifier checkbox flags. Oh, this is on a struct because Ignacio like frickin' does that. Okay. It's very C++ way to do things. Okay, so checkbox flags is a member of a struct. However, it's a polymorphic function. So we're going through this struct. We're trying to figure out the alignment of the struct. This declaration should be constant. Oh, it's scope entry flags. Oh, this could be incorrect generally. What is it called? So if a struct has a constant member that doesn't take storage, so this is totally unrelated to anything that we're doing. It's just we caught it. This already was a bug. It might cause structs to have bigger alignments than they would otherwise. Probably not very often. Okay. Let me go back to this and mark it no check-in. Actually, no, well, We might want this and change the thing. Mobile port of Steven's sausage roll. Dude, sweet. Sweet. Yeah, Ignacio just likes to do, I mean, to be fair, I think he did that like way before we had as many namespacing features as we have now. So he like wanted to namespace things, and that's how you do it. It's just for my personal aesthetic. I just think that that part of C++ is really gross, and I just don't do things. Also, I think it's because I know what the compiler does internally for stuff like that, and I just like, I just wouldn't do it. And I could see how just a user of the compiler would do it and not think anything of it. So no, yeah, I don't know. It makes sense that he did that. Okay, size. Okay, what is it? What are we even looking at? It inferred type. It's polymorphic. So we're kind of checking the wrong. Okay, wait. Same thing. Oh wait, it is constant, right? Constant storage size. So we're checking this polymorphic flag. This isn't my code because I don't space things out this way. And this is incorrect, I guess. 332. This isn't my code. Somebody probably did this to fix a bug, but yeah, so polymorphic is whether the struct as a whole is polymorphic. It's not sufficient to test that. Really what we just want to do is assert size here, because that'll take care of this. So yeah, it's not obvious, but the struct could be non-polymorphic, but it could have a polymorphic constant procedure member. It's very easy to not be clear about that. In fact, if I were reviewing the check-in, I probably wouldn't have noticed. Same thing here. And in fact, this was, yeah. This was all hunting down the same thing that we're fixing right now. It's the only reason you would assert on size like that. Yeah, so what I don't do is put procedures inside a struct declaration as if they were member functions, but they're not. Like they're like static members, right? I just think that's gross, but you know, he doesn't. So that's all. Okay. Num bytes. Base address, num bytes, segment instantiated size. Interesting. What? What is going on now? We've somehow got inconsistency. I wonder if this is something about what I was saying, where we compute a size too early and then it ends up being wrong. If I've been beta testing Inkrpar's new games, no, I haven't. Okay. Well, num bytes is 8. I mean, this might be a good stopping point. It's just maybe we're so close. Okay, let me just see. What's the funny business? UI dot, again, 1839. Okay, so we're looking at this. There's all these member functions. I kind of don't. Oh, it's constant storage. Right, so this is one thing that's gross about this, is because these are all member functions, the type info for this struct contains pointers to all these, which of course means we have to do frickin' pointer fix-ups in the type table generation, which is slower. Like, just all this stuff happens that you don't think about normally. Okay, I suspect that stuff like this guy is not being allocated in the constant storage, but is being done here. Like, we need to actually skip over this guy. Oh, wait, we checked the size. What? Okay, there must be an inconsistency, because we compute the constant storage size right here. We get the size. If it's instantiable, we get the constant storage size. Okay, great. If it's constant. Okay. If is constant, So these should be redundant, but this should just cause us, oh wait, source decal. What? No, because we computed the size off decal, not source decal. Okay, this is weird. Why are we? Okay, hold on. What is the difference between these things? Decal. Decals. Okay, let me get into an editor where I can frickin' read things. Type table line 285. It just looks like inconsistent code. Decals is just a set of everything we want to export. Okay. And then we assert size and do this. But then down here, we look up source decals. So I assume that assert's going to fire, because otherwise I'm not sure what's going on. Oh wait, source decal, inferred type. That's got to trip, right? Right. It's got to trip. Okay. It didn't. What is going on? Okay. Segment instantiated size is 530. Wait, we're in a different place. Okay, wait. Okay, we just need to move this once. No, these are the same. What? 530. Did the sizes of these like change? So first of all, how did we get a not multiple of 8? I guess because we have early struct parameters, whatever. This is so weird. So def in here is a type of decal. which is this. We're just going to move that up. That's still not going to go off. But base address 528, 530. Base address 528. Constant storage cursor 528. Constant storage cursor. Did it like start at a non-zero? There's 130 things. How are there 130? What? One, two, three, four, five, six, seven, eight, nine. I guess there's could be 130. Especially if it's using, maybe there's a bug and things are in there twice. There's no using. Is there? No. Maybe there's a bug and things are in there twice. Anyway, what is happening? Somehow, this is one of those weird cases where like everything looks right, except of course I'm ignoring something obvious. It's just too many members to like visually look at here. Okay, there's some serious nonsense here. Like, okay, all the declarations that we care about are constant. We collect some non-constant ones, but we don't do anything with them. Oh, I guess we do the member. Okay. Never mind. Never mind. See, this should just be a strict subset of what we did before because it was constant. It should come out smaller. Okay. So here's what we're going to do. This is really gross. we're going to look at where this is happening. And we're going to go printf I don't want this there. Let me read the frickin' text. Dude, I hate this. I know about printf. Thank you. All right, so we just want to do this. And then I don't know if the indices will come out the same, but put this down here. Right, so we're printing the index, how big each one is in the total, and then we're just going to print that here. I don't know why I made that static. That's stupid. It's just I'm tired. Late at night. Wait, we don't want this one to be static either. Why did I do that? I don't know, dude. My brain. Okay. Whoa. Okay, I forgot something. I forgot to check the serial. Oh, no jobs. There we go. Okay. To output.text. That took way too long for what we were doing. Where's our printfs? What? Okay. I guess we'll copy from the console. Wait. Doesn't look like the right number of things. A goes up to 72. What is going on, bro? B is much bigger. What? 80. Okay, by here we've diverged. Wait, we've got some size minus ones. That's not good. So we're not asserting size on these. I thought we were. That explains, so this size is -1 and this one isn't -1. Okay. I should have guessed that, honestly. Why? If I'm this stupid and I can make a compiler, y'all can do it. We assert size right here. Why are we printing -1s then? Oh, because they're frickin' polymorphic. I forgot about this. Duh. Duh. Oh my God, guys. See this? See how we have size greater than 0 here? Remember how I was looking like, why do these diverge? Because I'm a dum-dum. Right? I'm just too tired. Like, assert size doesn't mean the size is not -1. It means it's not -1 if it shouldn't be -1. All right? Okay. Really? Okay, less than or equal. Why is this less than? Size 4. Oh, because we're about to overflow it. Wait, what? How did this happen? A has no elements, I guess. Like what? What, people? We're way earlier. Okay. We are way earlier in compilation than we were before, which means we broke something with this. That wasn't broken. Oh, because, okay, this is the wrong thing. This is the sign that I must go to sleep, okay? Okay, wait. So def in here, okay, this is confusing because we have a thing called def in the outer, yeah, okay, this is no. That's why I goofed that. We have variables called the same name. Hopefully I did all those. Wait, oh my God. Could it be? Could it be? Oh my God. We're going to have to do a big sweep over this code because it's more crufty than it needs to be. And we're going to need to do some stuff like clean up what was it called? Conditional init size. Remove any of the especially messy assert sizes. I think we're going to leave a lot of the assert sizes in there for a while to catch problems, but some of them have like blocks of 10 or 15 lines of code around them, like where there were loops around it and stuff, and we can get rid of those. Yeah, okay. I suspected we might. Attempt to take size of unhandled type. Okay, that is just my init size triggering on things that it wouldn't have used to. So I'm going to leave it there. I think the rest of the problems here are going to be very easy to solve. I just don't want to do it while I'm tired because it'll take longer. But like, oh, let's test that we could run Sokoban. Like once we can compile and run Sokoban, any of the problems that are going to happen in the test programs about type sizing are just going to be little one-offs that don't really matter and are easy because we did the hard part. So this is good. This is very good. I just want to do a release build real fast, see if we got any time from it. Because assert size shouldn't do anything in release build. I doubt that we will see a noticeable time change, but we might. We might, probably not. I could run a telemetry build though. Show you guys. No. Yeah, it's still like 0.96. No surprise. Like we got rid of a small number of computations that were redundantly happening. Not enough to be like a big visible win. The big visible win comes in a little bit when we can parallelize that part of the code that we didn't used to be able to. However, in order to parallelize that part of the code, we also need to get things added to the type table. And to do that, I mean, audit that inferred types are not set until they are filled out. Yeah. So I'm a little worried about this one. I hadn't thought about this, but this is like an easy thing to break accidentally. So I want to think about a way to make that less error prone. But yeah, okay, we've had success. We are able to build and run Sokoban with all the pipes generated early, or all the type sizes generated early in the pipeline. That's good. It's good. Carmack's Joe Rogan interview. Yeah. Did they say when it's going to be? I feel like John Carmack decided to be a lot less picky about game programming at some point. I'm not sure why. Anyway, thank you everybody for coming by. We sure learned a lot tonight about algebraic data types in WebAssembly. It's been good. No, Carmack announced he's going to go on Joe Rogan, so that's going to be sweet, dude. Thanks, everybody. And we'll see you maybe in the morning. I don't know. It depends if I wake up early enough. We could do some more things. See ya.